Hey everyone, welcome to the channel. My name is Michael Nero. I'm a software engineer. So this channel I'll be talking about software engineering and in particular building on Internet Computer. So what is Internet Computer? Essentially, it is a network that allows developers to build applications 100% on chain. This includes backend services, data storage, file storage, assets, images, those things, as well as the actual user interface that users will interact with. All of this is stored on chain and is therefore tamper-proof and much more secure than applications built on centralized providers such as AWS and Google or Microsoft Azure. All right. So what makes the Internet Computer unique? We're just going to go through the website here and get an understanding of what Internet Computer is from their perspective. All right. So what makes the Internet Computer unique? First point they have here, smart contracts serve the web pages. So you can open Canister smart contracts directly in your browser, just like regular websites. Right? It's pretty amazing. And this is what enables the end-to-end development of applications, right? So in the current crypto ecosystem, you have a bunch of applications that claim to be on-chain and fully decentralized, but the truth is they're serving the applications through Amazon Web Services or some other cloud provider, right? And the problem with this is that with crypto in particular, this is especially a problem because if the value for the crypto tokens come from the fact that users think this stuff is on the blockchain and they think that their assets are secure and that they're theirs, but it's really not the case, right? A developer with a secret key or some backdoor access can go in at any time, make changes to the code, make changes to, I don't know, like the tokenomics. They can do literally anything. They can bring the whole thing down if they wanted to, right? And there's nothing really stopping them from doing so, right? And this is not just in crypto. This is the case with any application that is hosted by or hosted on one of these centralized providers, right? Say I'm building an application and everything is hosted on, all right, think about this. Yeah, let's say I'm building an application and it's like a tenant-based application, which like imagine like Wix, where each user has like their own domain, or like Shopify. Each user has like their own domain for their store. If there's a store that I don't like, I can just literally go into the database and delete the store, or just change things about it, make it harder to find for users, or just there are infinite amount of ways I can tamper like with the store, being the developer of the platform, right? So by having smart contracts serve application content as well as storing data, this removes the possibility for developers to do this, or even other malicious parties such as like hackers and anyone who may want to go in and wreak havoc, right? So smart contracts are stored on chain. So code is stored on chain. You can't go in and change it unless, well, you can change it on Internet Computer. There is a process for doing that, which I'll go over later. But the code is tamper-proof, so can't change it without anyone knowing about it, I guess is a better way to put it. Right, and then the next point here is users don't need tokens and wallets. So on the existing crypto landscape, the way that applications run is that for each user interaction, they'll have users pay like some fee, like a transaction fee, in order to process the transaction on the network. And these fees can be a lot of money, especially if you're interacting with the application a lot, right? And this is like completely different than how we're used to interacting with products on the internet. Like on Facebook or Instagram, for example, you don't have to pay like 10 cents every time you like someone's photo, right? That would be possibly like undesired experience, I guess, right? So Internet Computer does this a bit different in that they have something called a reverse gas fee or reverse gas model, right? In which developers pay for computation on the network, and users just go in and use the applications as normal. Yeah. The other point here, uh, aside from the gas fees, right? Users don't need wallets. So with a lot of these applications on like Ethereum, Solana, whatever, you need some wallet to store your crypto assets, like maybe MetaMask, which is a browser extension where you have to send your crypto to that wallet, and then you can use your wallet within like those applications to do things and buy things. Right. On Internet Computer, each application, there's not like a single wallet that you use to interact with all of the applications, right? Each application, your user account will act as a wallet, and you can send crypto there, sign transactions, and so on, like from your canisters. Right. So this eliminates a lot of the security issues with using these crypto applications, especially with like the browser extension wallets. Like those, I think, can be easily hacked. People have lost a lot of money as a result. Right. So the other reason that this is nice is if there is an issue with one of these platforms or one of the applications that you're using, any problems with the wallet or with your assets are localized to that individual project. So for example, let's say I have a wallet in Discover that has some ICP. If there's a bug in which all of my ICP gets drained, then it only affects the ICP that I have in this application. Where in contrast, if you use something like MetaMask and there's a bug, that wallet is likely the wallet that you're using to interact with all of the applications across the network, and that wallet would then be drained, right? So much more exposure, much more of a surface for exposure to risk using MetaMask or something like that. So Internet Computer solves for that issue, right? And then the next point they have here is around scaling. So Internet Computer consists of different subnets, 37 subnet blockchain combined into one platform. And then each subnet has nodes in it, which are just machines. You can think of them as like servers that are operated by independent node providers, right? So there's a process that is outlined for individuals to become node providers or companies to become node providers, right? There are guidelines around the type of hardware that you need to use, and the process that you need to go through in order to get approved to become a node provider. Right? And we'll touch on that a bit more going through the network. Right? And then the final point that they have here is around internet identity. And this was really the first thing that I noticed. Was it just felt like the future, like the first time I used it. It just immediately made me realize how different Internet Computer was. All right, so this is a decentralized identity solution that is provided by Internet Computer. All right, it allows you to easily access any applications on the network with one single account, right? One single identity. But the identity is used to anonymously authenticate, like across the different services. All right, so where in traditional web, we currently have different ways to log in. Like you can log in through Google, you can log in with Facebook, Apple, whatever. In all of those circumstances, whatever organization you're using to log in, they have final control of the data that is used, right, to log in. So Google knows all of the applications you're using with your Google account. They have data on that stuff, and they can sell the data or use it for whatever. Right. With internet identity, you get a very similar experience, but without the tracking. Right. And then the other thing that's nice is it uses these internet protocols, right? Like web authentication framework, which is, I think, supported by most browsers at this point. It provides a secure way for you to store passkeys on your devices. Right. These passkeys essentially link an application and the browser to a user, and you can authenticate that way. And then similar to like some of the more security focused applications that you may have like on your phone, like a banking app or something, you can use a biometric authorization. So either Face ID, fingerprint sensor, or whatever, right? Provide strong security, cryptographic key, never leaves your device, no password to use to authenticate on ICP. So I think this internet identity, in my opinion, is one of the large selling points for internet computer. Right, so this is just really the basics. I'm not going to go through all of these pages, but I recommend you really explore this website and learn as much as you can about ICP, because in my opinion, it's the future, and it is very interesting. It's interesting at the very least. So what is a good next step? Let's check out the NNS. So this is the NNS, or network nervous system. Network nervous system is essentially software that governs the internet computer. It manages any changes to the network, and any changes must go through this system. This is done through proposals, which holders of ICP tokens need to can vote on to either adopt or reject the changes, and they'll happen on the network. So I'm gonna go through what that is like. All right, so let's first sign in. We can see an example of what it's like to use internet identity. So this is a number that is unique to my internet identity account. So I'll just hit that. You get this pop up. Google Chrome is trying to verify. I can use Touch ID or enter my password. And once I do that, it'll access the passkey that is stored on my computer and use that as credentials for me to log in. So here you can see all the tokens that exist on the network, right? Starting with internet computer, this is the core token of the network, as you can imagine. You have some chain key tokens, which are kind of like internet computer twins of Bitcoin and Ethereum. Then you have tokens for all of the different projects that exist and are used for governing these projects. Right. I'll probably go over some of these at some point, but not right now. Right. Then in this tab, we have, you can see the different neurons that you're holding. So you can hold neurons, and what a neuron is pretty much just some ICP that has been staked for some time period. If we look at this neuron, I have 500 ICP staked for 8 years. So what this means is for 8 years, I can't unstake this ICP and sell it in exchange for something else, right? This is here, it's locked, and it's just what it is. If I wanted to get this ICP out, I would need to start dissolving this neuron, which would take 8 years, hence the dissolve delay. As the longer time period you have for your dissolve delay, the more of a bonus you get. Right now I have mine at 8 years, so it would take 8 years to dissolve, but I get maximum voting rewards, right? Which it essentially doubles the voting power that I have. And then you can see how voting power is calculated. Your staked amount is your principal, pretty much, so the amount of ICP that you have staked, and then you can earn maturity by voting on different proposals in the network, right? And as you vote on proposals, you'll get maturity, and you can either stake this maturity or spawn a neuron in which you can convert it into ICP, right? So we have the staked amount plus your staked maturity. Multiply that by 1 plus your age bonus, which is the amount of time that the neuron has been alive, and then multiply that by 1 plus the dissolve delay bonus, which we see here, right? And so that's how voting power is calculated. Very transparent and easy to figure out, right? If I wanted to, so right now I've been voting on proposals. I have 1.39 maturity available. So I'm just gonna go and stake that. Right, played a little waiting game. And one of the beautiful things about internet computer is that as you stake your maturity, when you go to vote on proposals, your amount of voting power is going up. Like every time you stake, this increases your voting power. And the more voting power you have, and the more proposals you vote on, the more maturity you earn. So there is a compounding interest effect that comes with this. that comes with staking your ICP and neurons and voting on proposals. If you don't want to go and like manually vote on every single proposal, you can provide you can identify like which neurons you want to follow. So there are some like kind of publicized neurons, they're named neurons that you can follow. I'm choosing to follow the Affinity Foundation. This is the nonprofit organization that actually created Internet Computer. Right, so I follow them for some proposals, but I try to vote on most proposals myself. But if like in the event that I don't vote on proposals, then my neuron will vote the same way that this neuron was voting. So it's kind of like you can delegate someone to represent you if you don't want to vote, which in my opinion is the way a real life democracy probably should be working as well, right? And moving from the nervous system, well, let's just also look at some other projects, right? So I think I also have tracks, So same thing for any project, any SNS DAO that you are a member of. They work pretty much the same way. You earn for voting on proposals, you stake your maturity, and just keep it going. Either you dissolve and take your money out, or you keep your stuff staked and you can continue to vote on proposals and make changes to the applications as you see fit. So this is a very powerful way for people to start having ownership in the applications that they use and that they care about. Right? If we look at Internet Computer proposals, let's just see. I only want to see the adopted proposals right now. So there are a few different things that you can do, right? You can make changes to nodes on the network. You can add node providers or remove node providers. You can update the code on the network. So like this UI that we're looking at, you can, like, in order for it to be changed, there would need to be a proposal that comes in here, and it would need to be adopted by all of the neurons, well, by a majority of the neurons that vote. Right, so let's look at one of these votes, or one of these proposals. So this is a proposal for updating the NNS canister, right? And NNS is this application that we're on right now. So we can see how many people voted. This has 99% yes to pretty much like 1% no, right? So this is 461 million voting power in favor versus 300,000 against, right? So there are a few ways that a proposal can be adopted. First way is by immediate majority decision. So that's this halfway point. If either at any point, if 50% of the voting power votes in favor or votes against, then the proposal will either be adopted or rejected. But let's say we don't hit this 50%, but the deadline for the proposal and for voting on the proposal is up. If 3% of the total voting power has voted in favor, then the proposal will be accepted. Right? And these proposals, like this proposal in general, I mean, in particular, is pretty interesting because it comes with code that gets executed once the proposal is adopted. Right? So you can see in the release notes, we have some commit logs here, but these are code changes that someone is requesting be pushed onto the actual network. This identifies the commit for like these changes that contains all of these changes. And then this is a WASM hash, and this is I think it's like a representation of the actual code or like the actual bytecode in the WASM. It gets encrypted into like a hash that can then be verified when people are reviewing the proposal. Right? So if we look at these verification steps, right, you want to fetch the repo, or pull latest changes like for the repo, check out the commit that is mentioned here, right? And then you do this build, whatever, and this will give you a WASM hash that should match the WASM hash in the proposal. Oh, wait, no, this is the current, right? So it should match this one. And if it doesn't, that means there is some code in here that is not actually represented like in this proposal, and potentially a malicious like proposal. So in that instance, I think I would decline. But if everything looks good, approve, and yeah, and go on about your day, right? So those are like some of the proposals that are available, and essentially the same thing for any application that was launched as an SNS, right? Yeah, and here you can see, this is the launch pad. You can see any applications or any projects that are going through decentralization swap right now or have gone through. And you can participate and become an actual member of the DAO and vote on changes. So here we see all the different parameters of the swap, how many total supply there is, how many tokens are being distributed to participants, minimum commitment, maximum commitment numbers, and like when is the swap over, right? For this swap, Sonic received 519,000 ICP, which is pretty beefy. I'm not exactly sure the math on that or what ICP was even, what price ICP was at that point, but sure it's a lot of money. So that is awesome that a developer can go in and create a project and have a path for funding the project, and then also for decentralizing and making it open for the community to control. Right, and that's the goal that I have here. I want to build projects where the community is in control. I am not the sole developer, the team that I'm working with is not the sole team. I think the world would be much better, and the products that we use would be much better if the actual users had more of a say, more control in like the direction of these applications. Like if we could choose what Facebook did with our data, if we could choose the way the algorithms worked on these platforms that are recommending content to us, if we could choose who gets banned, what type of content gets moderated, like all of that stuff makes a huge difference in our overall experience. And I think it will have a huge impact on the world in general, right? So that's why I'm excited about ICP. I invite you to do some more research, learn about ICP. It's pretty amazing, and very transparent, right? Yeah, so the final point that I have is just to share the dashboard with you all. Internet computer dashboard. You can see a bunch of metrics about activity on the network. You can see where node providers are located. And this map gets more populated every time I look at it. It's so amazing. Like, I feel like last time I checked, there weren't any in Africa, and that was maybe like a week or two ago. But I don't know. Don't quote me on that. But yeah, it's pretty cool. You can see where activity is happening and growth is happening. You can see how many canisters are existing on the network, transactions, cycle burn rate, power consumption. Yeah, it's pretty amazing. And you can also see how everyone is voting, how many people have their ICP staked for how long. It's like everything is extremely transparent. So yeah, with that being said, I think Internet Computer is the best place for developers to be building on. If you want to embark on a new journey in development, this is where I'm spending most of my time. Yeah, so in the future, I'll have some more videos, probably a little more in depth about some of the topics I covered in this one, but just a little more focused. And I'll also be doing videos on how to actually build applications on the network. Like, comment, subscribe. Thank you for watching. It's always great. See you next time.